Creating a GRS surgical model to vacuform a GRS surgical guide is simple. Blue Sky Plan is used exclusively as the primary surgical implant software, and currently we're using the Tangential 5 perspective in advanced mode and have already completed designing the surgical implant case. As you can see, all of the necessary surgical parameters involving position, orientation, and depth of the implant relative to the bone, nerves, and future restoration have been established. Seeing that the implant planning has been completed, go up to the top of the screen and find the visibility toolbar and toggle off all virtual teeth, projections, and locks that may be present. Then go over to the right of the screen, click on Surfaces, and under CT Surfaces, uncheck the visibility of the original CT scan. Then, under Implant List, highlight the specific implant and confirm that the Drill Guide Visibility checkbox has been checked. It is also critical that the specific guide tube dimensions for each specific implant have been manually entered in order to ensure that the selected GRS surgical ring will fit in the designated edentulous area. The dimensions have been provided on this video under the Implant subheading and can also be found at grsguidesystem.com. For this video, we will be using the dimensions required for the regular GRS surgical ring and have made the respective changes to the guide hole diameter and height dimensions in order to validate the fit of the chosen GRS surgical ring. After the fit is confirmed, make sure that the upper surface of the guide tube is visible through the STL model in order to ensure that when a GRS model is created, the hole will extend through all STL surfaces. By default, the guide tube is usually above the tissue level of the edentulous area designated for implant placement, so no adjustments are usually needed. However, to adjust the position of the guide tube, simply go back to the Guide Tube subpanel under Implant List and use the Offset feature to raise or lower the guide tube as you see fit to ensure visibility. Now, seeing you're ready to create the GRS model, click on File in the upper left-hand corner of Blue Sky Plan, and on the drop-down menu, go to the Export To feature and simply click on GRS Model. Depending on the size of the model and the processing power of your computer, the model should be rendered relatively quickly. Once the GRS model has been created, go to the right-hand side and click on the Surfaces panel and uncheck the box next to the original STL surfaces. Then, highlight the newly created GRS model and toggle the Transparency feature under the Materials submenu to visualize the planned implant. Then, go to the top of the screen and toggle off the implant icon. As you will see, this provides virtual confirmation of the hole's position and orientation, which, as you will see, is exactly as the implant was planned. It will also provide you with an example of how the model will appear when printed. Now, once all surgical requirements in the GRS model have been confirmed, simply go to File in the upper left, click on Export Data, select the export quality for the model, uncheck any unnecessary export items so that all you will be printing is just the GRS model as a separate file, and click on Export. Confirm the name associated with the new GRS surgical STL model and location for the file to be exported, and click OK or Save. Once the model has been printed, simply use a GRS vacuforming assembly consisting of a locator pin, surgical ring, and protection cap to create the most accurate and form-fitting vacuform surgical guides available today. Other videos describing the complete GRS guide system and surgical components, guide fabrication techniques and applications, along with a virtual surgical procedure outlining the seamless step-by-step surgical sequence when using the GRS guide system can be found at grsguidesystem.com. The GRS model is now ready to be printed either in office, by your lab, or simply through grsguidesystem.com.